Always worth going through the worksheets, even if some of the questions are a little bit more trivial than others. Which of the following not an organic compound? Well, methane, CH4, it's got those carbon-hydrogen bonds. Ethanol, CH3, CH2OH, got a carbon-hydrogen bond. Chloroform, CH3, you can see that CH bond. By the way, CCl4 would also be an organic compound, not because you've got a carbon-hydrogen bond, but because organic chemists think of halides and so forth very much like carbon. So for them, a carbon-chlorine bond would make it an organic compound, even if you don't have your carbon-hydrogen bond there. No doubt whatsoever about carbonate, however, CO3 2-, no hydrogens there, no pseudo-hydrogens for organic chemists to get excited about. Carbonate, very, very definitely an inorganic species. What's the name of this? CH3C. Now, one of the things that I hope I discussed sufficiently in the first movie is that the different ways of drawing organic structures have different uses. And this one here is really not very useful for determining the name. So I would go ahead and I would immediately draw out, if not the skeletal structure, at least the condensed structure. So let's see what we got here. CH3, CH3. Then I got a CH, CH. That CH bonds to CH3. There's the C of that bonding to a CH3. Carbon next, that's got two CH3s on it, going to a CH2, CH2, CH3. Hopefully you can see that well enough. Now once I've drawn it like this, then naming becomes a lot easier. I can immediately see my nice long chain of 6 carbons, thus it's a hexane. I have 3 methyl groups there, thus it is trimethyl, and then I will start numbering at the end that's closest to the group, so therefore we got that one there will be 2, so we'll start numbering at the left, which is nice, and so it becomes 2,3,3 trimethyl hexane. Drawing it like this, it's fairly easy to go to the skeletal structure. There's a 1, 2, 3, 4, 5, 6 carbon chain, methyl group coming off the carbon 2, 2 methyl groups coming off carbon 3. Talking of skeletal structures, there's this one here. First thing, get the longest chain. Well, even though there's all kinds of weird branches and everything coming off it, there's the longest chain there, and it's a nonane, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. See what we've got tucked away on it. We've got 3 methyls, so there'll be a trimethyl. We have a 2 carbon group there, so that's an ethyl, and then we have a 3 carbon group there, will be a propyl. And when we get to naming it, it goes alphabetically, so the ethyl will go before the methyl, even though it's a T-methyl, it's still methyl before the propyl. Now, the numbering scheme, we could start at this end, we could start at this end. Here, the first, if we started here, the first branch would be at carbon 3. Here it's at carbon 2, so therefore we will start numbering, go from left to right. And that means the methyls at 1, 2, 3, 4, 5, 6, and 7. So 2, 6, 7 trimethyl. The ethyl here is at 1, 2, 3, 4, 5, 6, carbon 6. And the propyl group is of 1, 2, 3, 4, 5 carbon. So 5 propyl. Now putting those in the alphabetical order, as we said, ethyl first, C6 ethyl, 2, 6, 7 trimethyl, because M comes before P, and then 5 propyl. Drawing it out funny ways, there's the condensed skeletal structure, or the condensed structure, so putting all of the carbons in as their little group. So we've got a CH3 at the end, then a CH, going to a CH3, going to CH2, CH2, then we have CH with a propyl group coming off it. You could draw it C with a CH2, CH2, CH3, much easier just to condense it to C3H7. Carbon 6 here has got a methyl and an ethyl coming off it, and carbon 7 got a methyl. Drawing it that way, pretty disgusting. I would recommend that if anybody ever gives you something like that, you immediately draw it out like this.